my empty cars data frame contains cars, and I'm going to split the data frame into groups according to the gear column. So when I run this line of code, I get a list. Split always results in a list with 3 objects. So let's take a look. I have cars with 3 gears, I have cars with 4 gears, and I have cars with 5 gears. Now, before I can check which function I need to use to compare my groups of cars, I first need to know if the data or the residuals are normally distributed. Now, when I go back here, I can see that I have a group with 15 cars, I have a group with 12 cars, and I have a group with 5 cars. Yeah, these two are medium-sized. Yeah, that's what I call medium-sized. It's between 7 and 25 to 30 measurements per group. So this is medium-sized. So for 2 medium-sized data sets, I can check normality of the data using this function. Okay, that means that I can use that function to check if the data are normally distributed. What is the data? The data is one of the columns in these data frames. It's a column that contains the gas usage, miles per gallon. So I want to see if cars with 3 and cars with 4 gears, if they have different gas usage. That's what I want to check. That means that for each of these 2 groups, I have to check if these gas usages are normally distributed, yes or no. What is the issue with the Shapiro.test function? The issue is that it will only work on vectors. Very important. Just like most functions in R for statistics, this is the same. It only works on vectors. So if I want to check normality of my groups, and I want to do this in one line of code, I can use lapply. Yeah, list apply. So the apply that you can do on a list. Why on a list? Because that's what we have. We have a list with 3 data frames. So I'm going to do lapply. What do I want to do? Well, I want to check for each object, for each data frame, for each group in this list, I want to check if the gas usage column, the MPG column, yeah, is normally distributed. Shapiro test, this function, will produce a lot of output, and one of the things that it will produce is a p-value. So the result of this function here of Shapiro.test is a list itself, and in that list there is an object called p.value, which gives me the p-value of the Shapiro test. Is this p-value larger than 0.05? Then yes, the data are normally distributed. Is this value lower than 0.05? Then no, the data are not normally distributed. So I'm going to apply a function. Why a function? A function, well, because I'm not using the default input, as you can see here. Yeah, I'm not using the default input. The default input would be x, completely x, the total of x. And I don't want a total of x. I want to have this column from x. So I'm not using the default input here. So I need to explicitly write the word function. Function in x. What is x here? Well, it's every data frame from this list. Every object, every data frame from this list. What do I want to do with x? I want to retrieve the column called MPG. I want to check with Shapiro.test if this column is normally distributed. And I want to return from the result the p-value. So when I run this line of code, you see that you get a p-value for each group of cars. And all the p-values are larger than 0.05, so we can assume that the data are normally distributed.